get it out of there.
Ready? Hi, I'm Grace Kevin. This is my informative speech on how antibiotics work and antibiotic resistance. So, antibiotics were discovered by Alexander Fleming in 1928. And the first antibiotic ever discovered was actually penicillin, and it was discovered by an accident. Alexander Fleming was working at a hospital research center in London where he had actually been on leave for vacation for about a week. So he came back in and he was looking through some old petri dishes, and he had left bacteria and fungi growing in a couple different dishes. And then he noticed in one of the dishes there was a mold that had started to grow in the dish, but there was a ring around the mold where a weird juice-like substance had been secreted by the mold, and everywhere that his mold juice was found, there was no more bacteria or fungi. So at about this point in time, there were about 63,000. Every patient in the hospital pretty much died from an infection. It didn't matter if you had a simple cut, you just got cut on the job. It didn't matter what happened pretty much. If you got an infection, all they could really do was wait and hope that you were going to make it, because 30% of all deaths in the country at this time occurred from infections. So antibiotics were not man-made, they were just accidentally discovered. So after Fleming discovered his mold juice, he assigned his assistants Craddock and Riley the task of isolating the juice, which actually took about 11 years, because it wasn't until 1939 that they were able to finally isolate it, and then they could start working on purifying and researching the composition of the antibiotics. Now, the U.S. National Institute of Medicine and National Institute of Health is where I got my information on penicillin and the history about it, and the American Chemical Society is where I got the information about Fleming referring to his penicillin as mold juice and how he assigned his assistants to work on it. So antibiotics work, they're very extremely specific. Each antibiotic has its own set of DNA, and sometimes random mutations can occur in the DNA. So if even one letter is off, the DNA sequence can come resistant for the strain that it's actually supposed to treat. So antibiotics work, each one targets a specific sequence or series of DNA. They have different class types. Like penicillin is a B-lactam antibody, meaning it targets the B active receptor of the gene. So penicillin works by inactivating the transpeptidase enzyme, which is necessary for the cross-linking of bacteria cells, which creates the cell wall. So basically penicillin works by breaking down the cell wall of an antibody. So a couple different types of antibiotics are tetracyclines, fluorochorolines, sulfa antibodies, which are also known as sulfamides. And antibodies, like I said, work for different classes, and then according to healthline.com, they are extremely specific. If you take the wrong kind of antibiotic for your infection that you have, nothing's going to happen, and then your cells are more than likely going to become resistant because you didn't need that antibody. So on your body, you have 70 trillion bacteria colonies on you in total. 40 trillion are not from your body, 30 trillion are from your body, but only a very small percentage of that is actually dangerous and can harm you. So the way we get bacterial infections is all of our microbiome is composed of small, tiny bacteria cells all over your body. Like I said, there's 70 trillion of them. So most of your bacteria has a place that it normally lives on your body. The problem arises when the bacteria cell moves from that region to another region. Like E. coli bacteria, which can commonly be lethal, is found in your gut. And as long as it's in your gut, it's fine and nothing happens. But the second E. coli bacteria starts to move outside of your stomach and intestinal area is when you can contract the E. coli virus. So antibiotics can be taken several different ways. They can be taken as a tablet, like a pill, or a cream, a liquid, or an ointment. Now, most antibiotics require a prescription, but in some cases they do not, and they can be taken over the counter. While antibiotics start acting in just a couple days, they may take up to a week to help you actually notice the benefits of it. Now, antibiotic resistance is a pretty new problem, but antibiotics are also a pretty new issue. So our cells all have specialized parts, but in antibiotics they tend to grow different parts. So if the cell has become antibiotic resistant, and that means it has a capsule around the outside of it. The capsule is basically a thickening of the cell wall that occurs, and it makes it harder for an antibiotic like penicillin to get inside the cell and deconstruct the cell wall. They also have the pili, which are like a little bridge that can connect the resistant cell to any other cell. So if you have a cell that becomes resistant to bacteria, they can easily pass on their DNA to every cell that surrounds it. And then if a cell is operating under less than optimal conditions where they don't want to be, they can actually take their DNA and close it into like a little ring, which makes it very, very difficult for an antibiotic to affect the DNA because it condenses it into a ring that they can't get to. And then these resistance can be caused by a random mutation like an accident, or they evolve over time. So when an antibiotic finally does, if you take the correct antibiotic and you take it for the correct amount of time, you're supposed to take your whole prescription, which is ideal when you'll finally kill your whole antibiotic. But if you don't take it for the whole specified amount of time, like on the prescription, then all the bacteria cells aren't killed, and some of them remain in your body, which is how we have the antibiotic resistance problem. So when you have resistant DNA and you don't complete your whole antibiotic, when that bacteria cell finally is killed, it releases the resistant DNA to all the DNA around it, which makes it really hard for any antibiotic to work in your body again, because then all of the cells in your body could potentially have the resistant DNA, which is how we get big infections like MRSA and meningitis that become so lethal. So antibiotic resistance has a couple different causes, which could be related to agriculture, feeding animals antibiotic for long amounts of time, failure to completely take your prescription, or borrowing a prescription for anyone else. So in conclusion, we haven't had antibiotics for a very long time, but they've been some of the biggest lifesavers in the world. So my 3 points in review were the history of antibiotics, how they work, and where we're headed with antibiotics. So antibiotics have obviously been one of the main lifesavers in our country in our medical history.